for taking some time to spend with us. My name is Chris Rosen. I'm the Program Director of Offering Management. I own the IBM Cloud Container Service. We'll get into what that actually is here in a few minutes. Really excited to have Dan Garfield here from Codefresh and one of our partners in the space to help us and help you as you're running in a multi-cloud or hybrid cloud environment to be able to automate those deployments, automate those workloads, regardless of where you're actually running them. So for an agenda today, we're going to talk about, Dan's going to get us started with the actual continuous delivery chain and what that actually means. Then we'll hand it back over to me and I'll kind of talk about IBM Cloud, our container service, and then we're each going to do a quick demo showcasing the IBM Cloud as well as Codefresh, and then we're going to wrap it up with some Q&A. So please, there is a Q&A in the tool. If you have a question, feel free to add it here at any time, and we'll address those at the end. So with that, I am now going to hand it over to Dan and let Mr. Garfield walk you through some of the Codefresh concepts.
Today we're going to talk about the CICD, and really the question is, how do we get from git commit to the Kubernetes cluster? In other words, how do we make a change and then have it appear where we want it to be? So we would say we want to figure out how to get from here to there, and what goes in between. Well, in between, we're going to have to figure out some stuff. We're starting from the git commit. So that means we're going to need to have a webhook, which is going to fire when code is changed, which is going to start a pipeline, which is going to build the image and validate the changes. And what are the changes? Well, the changes are actually two things. It's your code that you're validating, but more than that, it's actually your image that you're validating. And what is your image? Your image is a combination of your code at the top and everyone else's code at the bottom, because an image is really the combination, right? So this is what we talk about when we're validating. It's actually not validating just your code. It's validating your code and everyone else's code, which is another way of saying that we're validating the image. And that should be clear. I mean, this is one of the basic, core tenets of Docker and why it's valuable, why containerization is awesome. So at the end of this step of where we have now created this image, we can now push the image, which means the image needs somewhere to go, because we need an image repo, because it's going to store the image, and it's also going to record everything about the image, and it's going to solve the problem of provenance, which we'll talk about in a minute. And the whole point of that is so that we can roll forwards and backwards. Roll forwards and backwards where? To Kubernetes, right? This is where we're going to host our application. So now that we're cruising right along, the next step is we need to have a connection to our cluster. Why? So we can deploy to it, so we can monitor to it, so we can roll back, hopefully not often, and so we can modify that deployment. And we do all that so that our container can update smoothly. And what is your container? Your container is something that contains your image that we just built. Oh, hopefully this isn't too confusing. It's a bit of a Jacob's ladder to go through this whole thing. But your container is going to be basically the image that you built is going to run on your container, and hopefully it's going to run well. But your container is not everything. In fact, your container is not your application, because your container, in fact, your app is lots of containers, right? And hopefully they're all happy little containers. And if you remember, our whole goal was to figure out how to get from here to there onto our Kubernetes cluster. So there's kind of a final piece that we're going to look at in the process, which is that you need to scale all of this for your application. Remember, we started off with a webhook that was fired to build an image so that we could validate it. Then we could push it into our image repository so that we can have visibility into this thing. We can roll forwards and backwards, and then we could actually get it onto our cluster. And now we need to do it for lots of things. And I'm going to introduce the idea of validating image together, which we would call a Helm chart, and I'll explain what Helm is. And all of this is basically to validate our infrastructure as code. So the whole point of doing all of this stuff is so that your team can easily update the application, right? That's the simple goal, and we had to go through all these steps. So what does it mean to validate your images together? And what is Helm? Well, Helm, this is where it comes from. Your app is lots of containers, right? And it's not just the containers, but it's also how they relate to each other, how they network together, how they interact, right? And Helm is a package manager for Kubernetes. Okay, so it lets me say, I have this image that I want to run, and it needs to have all of these Kubernetes properties, and also it needs to work with these other things, and that's what Helm does. So to back up to a very high level, we're really talking about three components. One is your code repository. It could be GitHub, could be GitLab, could be Bitbucket. We don't really care. We need Kubernetes CICD, which is going to do this whole workflow engine that we've been describing, and we need the cluster. And the jobs of these things are basically, I want to have a place to commit code to, I want to have a place to validate and deploy that code, and then I need a place to host that code. So hopefully this is somewhat clear, but basically we went through kind of this introducing a lot of concepts. And as we go forward, Chris is going to talk about why IBM Cloud makes sense as a place to host Kubernetes. And then we're going to get into how we actually validate and deploy in a real world scenario. And we'll actually make some changes and watch code and pipelines fly. And so all of those concepts that I introduced, they should become much more concrete as we go along. Chris?
All right, great. Thanks, Dan. And you're absolutely right. So these kind of fundamental constructs as far as how we take these changes as we're developing new capabilities, new features, security fixes, and then how do we take them, actually move them and deploy those into production. So we're going to take another step backwards and talk about really the importance of containers and container technology. And they're not new. So containers have been around for 30 plus years, depending on your definition of a container, but they've really come to the forefront recently with the likes of Docker and Rocket. And we're really focused on Docker because of, really the simplicity and how easy they made it to consume this new technology. Regardless of the OS running on your laptop or in the cloud, you can install Docker and get up and operational very, very quickly. So all of us can become container experts very simply. Now, there's a lot of reasons for using containers and why developers gravitated toward this technology early on is because of, the ability to have that portability, the package up your application, all of its dependencies, and move it from one environment to the other. And we've all been in that situation where something works in my environment, but it doesn't work in yours. So clearly that's your problem, not mine. So containers has really simplified all of that. And by doing so, it allows us to ship software much faster than we could in the past, because now we're iterating so much more quickly. We're developing new microservices, which are small, concrete, business functions, and deliver them faster. Now, containers will also allow us to use our underlying infrastructure more efficiently. So because of the way they build on top of each other with the various layers, the containers are using those resources, whether we're using virtual machines or bare metal, much more effectively. And then the last point is really around that portability, because we want to eliminate vendor lock-in. We want to be able to take those applications, run them consistently, whether it's on-prem or in IBM Cloud or any other public cloud. So that being said, good leadway for what is IBM Cloud. We've got a public cloud that's operational in 60 plus data centers around the world today. The standard kind of infrastructure as a service layer that you would anticipate with virtual machines and bare metal and storage and networks and all those things. But really the focus of IBM Cloud is as we move up the stack and we get into these higher value capabilities, whether we're using Watson for our cognitive capabilities or weather data. That's why we acquired the weather company, was because weather affects all of us, and all of our applications need to be able to build in that type of intelligence and that logic. Managed databases, IoT. So really, as you're expanding your capabilities, you've got tools that you can build in and integrate regardless of the compute choice. Obviously, today we're going to focus on containers and Kubernetes, But if you're using something else from the platform, whether it's VMs or bare metal or Cloud Foundry or Cloud Functions, you can consume these capabilities consistently. Now let's get into the IBM Cloud Container Service. So we've had a container as a service offering since June of 2015. And this version of the architecture using Kubernetes was launched in May of 2017. So it's a fully managed Kubernetes offering. And its really premise is that, it's intuitive user experience around not only those day one deployment of your cluster, but then ongoing management of it. So it's really to abstract the complexities of all these open source projects, whether it's Docker or Kubernetes or Prometheus or Calico or anything in the stack. So that way you can focus on your business objectives, not becoming a Kubernetes expert. Just worry about the things that actually generate revenue for you and your company and your shareholders. So as you deploy those clusters, run that workload where you need it to run. If you have geographic regulations or rules, you can deploy, and all of the workload, all of the data will remain in that given country. And also consuming those other services that I talked about within the IBM Cloud Catalog. We are a certified Kubernetes provider, which essentially from an end user perspective means that you're going to have consistency. We've not forked what's available upstream. The same CLI and API that you use will work consistently here in IBM Cloud as well. So where can I actually run it today? When you think about, I need to meet GDPR requirements, or my particular country requires that I run my data and all of it remains in country, in the confines, in my own borders. So you can do that. When you deploy a cluster to any of these regions, the Kubernetes master, all of the worker nodes, they will remain in that particular data center. So you control where data flows. If data residency is important to you, then you can ensure that when you deploy, that workload stays exactly in that particular data center. So you can see here where we run today, that continues to grow and evolve based on kind of demand and where we need to run those workloads, but giving you that control. And as you start to build out high availability, then you need to think about, now I've got a cluster in this region and another region, and that really helps ensure availability and uptime for your applications. Now, at this point, we're really focused on open source. So I buy into open source Docker, open source Kubernetes, that sounds great. Why do I need IBM? Why do I need the IBM Cloud Container Service? There are 6 kind of main tenets that we talk about as our differentiators and reasons why you would want to use the IBM Cloud Container Service. The first is around simplified cluster management. And this is now on day one. We'll go through and we'll walk through the UI where we can point and click and deploy a cluster. And that's great for kind of a demo. But the reality is you're really going to drive all of that through automation. And that's where Codefresh comes in. You're going to drive deploying new clusters, drive deploying that workload all through CLI or API, because you're going to do so integrating to your DevOps tooling. And then we're going to help you manage it. So like I said, you don't need to become a Kubernetes expert. If a new version of Kubernetes comes out, will it break versions of Docker or other things? Is it secure? Is it performant? IBM is going to do that for you. The second thing is really around security and isolation. So only in IBM Cloud do you have isolation choices of not only virtual machines, but bare metal. You can run bare metal worker nodes as a part of your managed Kubernetes offering. For virtual machines, there are 2 flavors as well, as far as what we call shared compute. So it's a standard cloud VM, single tenant VM, multi-tenant hypervisor and hardware, or single tenant, which we call dedicated compute, and it's single tenant VM, hypervisor, and hardware. We also have something called Vulnerability Advisor, which will introspect every layer in each of your images for not only known vulnerabilities, but also configuration weaknesses. You can set a policy to block your users from deploying anything that has those vulnerabilities. So it gives you a lot of control and flexibility and makes security very consumable as well. We've talked about using other services from the platform. Today, there are 170 within the catalog. Again, whether it's Watson or managed databases, to be able to consume them within your applications that you now have running as containers. We also integrate with Identity and Access Manager, so you can define who has what level of access to your clusters. You may have different clusters for different life cycle within your application and control who actually has that access. It's 100% native Kubernetes experience. So the same CLI and API that you run on-prem or on your laptop will work in IBM Cloud as well. And then the last thing is around integrated operational tools. So we will give you out of the box monitoring solution and logging solution and security solutions. But if you are operating in a hybrid cloud or a multi-cloud environment and you've already standardized on a Splunk, a Sysdig, a Loggly, any number of players in this ecosystem, you can deploy those to your clusters running in IBM Cloud, take all of that monitoring or logging or security data and send it back out to that provider of choice. So operationally, you don't need to learn new tools. You can bring the tools that you're familiar with, which again is one of the things that I'm really excited about to be able to work with Dan and Codefresh, is that if you're using that and deploying workloads to AWS today, you can now do the same thing deploying to IBM Cloud and using the same set of tools that you're already building on top of. So the last thing that I want to touch on before I hand it back over to Dan is inevitably after I get asked about security, I get asked about, okay, who's using the container service today? We've got a number of customers. There is no one industry that is using this type of technology. The one that I like to talk about because it's in the financial industry and typically we think of them not being able to run workloads in the cloud, but the reality is they are, and a lot of them are. So one example is Bendigo Bank in Australia. Their focus is really about being the number one customer-facing, consumer-facing bank in Australia. And what they're doing is using these new technologies with containers and microservices in the cloud to develop these new ways to engage their customers, to make it easier if their customers need to interact with them, to ask about new mortgage options, new credit card statements. They can do that in a very intuitive manner. And all while maintaining that statement of record on-prem in their databases and creating a secure tunnel to be able to communicate. So there's a lot of use cases around when and how you should use containers, and we're definitely working with our customers as they go through that transformation to cloud. All right, so with that, I'm going to hand it back over to Dan.
Thank you. So I see that we're getting a number of questions as we go, which is great. We'll answer those as we get to the end. But to come back to this kind of high-level concept, this is what we're going to do, and this is what I'm going to demo. We're going to take a commit, and we're going to do a multi-stage build. We're going to build a Helm chart. Again, it's that sort of Kubernetes package of our entire application. We're going to run functional tests, and we're going to push it and then deploy it. And this is what I'm going to demonstrate in the demo after we show just how to kind of create your Kubernetes cluster with IBM. And this will give you a sense of how streamlined your development workflow can be, and some of the important elements. And one of the things that I mentioned earlier is provenance, which is basically being able to answer the question of what's running in production and where did it come from and why does it exist. And I think that this is going to be really key to understanding how all this stuff works together. I'll have a spot to show you that in the demo, and I think it'll all make sense. So Chris, you wanted to start, I think, with just showing how to create a cluster. Was that right?
What I've got here, I've logged into the IBM Cloud Console. Out of the box, I can see everything that I have deployed. So what we're going to do is jump into our actual, what we call our container world. So this has all of my Kubernetes clusters, my registry, my Helm charts, my vulnerability advisor, which is giving me that security insight. And we'll take a look at deploying a cluster. Now, as we walk through this, you'll see, depending on your account, you can create a free cluster, which will have limited capacity and duration for that to exist, or you can create a paid cluster, which is what we'll actually do, and walk through some of the capabilities that we've talked about as far as differentiators within IBM Cloud. So the first thing, I would have my region selector. I could pick any of the 6 regions worldwide that IBM Cloud is running in. We'll just use US South for this example. And as I scroll down, we'll skip the free and standard because, again, with the standard, there's a lot more options. It's a little more interesting. So I'm going to give it a name, something very provocative like demo. Within that region, I've got different locations. So these are data centers where the container service is supported. So you can see here I've got Dell 10, 12, and 13, which makes sense because I'm in US South, but you'll also notice Sao Paulo. And the reason is this is what we call a spoke data center, where if I need to run in Brazil, I can deploy my cluster to Sao Paulo data center. The master, the workers, everything remains in that geography, but it runs out of the US South region from a deployment perspective. So we'll leave Dell 13. We can see here my Kubernetes versions that we currently support. I'm sure you're thinking, well, 110 just came out a few weeks ago. Where's that? Well, we work upstream in the community, and when a new version comes out, we ensure that it is performant, secure, scalable, all the things that you want from a production perspective before we make it available to you. We actually found a regression in 110, so we are waiting for 110.1 to be available, and then we'll publish that here, and that'll show up. When 110X comes out, then we will remove end of life that support for the third or the fourth oldest version, in this case 17X. So let's just pick 193 here for this cluster. Now, for my hardware isolation, this is what I talked about before in IBM Cloud, where you have the option of shared compute, that's a single tenant VM, multi-tenant hypervisor and hardware. The dedicated compute, which I would be the only tenant on a physical piece of hardware running out in IBM Cloud, or bare metal if I needed some additional throughput or local storage or some other use case around why I would need that bare metal. For example, for this demo, I'll just pick a small flavor. Now, I can determine the number of worker nodes. Obviously, for an HA environment, I would want 3. I could scale up or down depending on my actual requirements. To keep my costs down, I'm going to go with 1. Now, the next thing is around private and public VLANs. Each of these worker nodes in my cluster will have a public and a private VLAN. If I have other resources deployed in IBM Cloud, whether it is virtual machines or bare metal, I can pick the same VLANs to have them co-located. Or alternatively, if I wanted to segregate that network traffic, I could deploy to different VLANs and keep that controlled and keep this workload separate from another. And then my last option here is to encrypt local disk. So by default, we're going to use Lux encryption to encrypt where your Docker containers are running. If you needed to remove that for some reason because of a performance test or something, then I would deselect that and say create cluster. Now, this is going to go off and magically deploy the master node or the API server for my Kubernetes cluster. That gets deployed to my infrastructure account. That's how we manage the offering. The worker nodes are going to go to your account. That's where they deploy. You own that compute, that storage. But instead of watching this deploy, which is not quite as exciting, we're going to take a quick look over at an existing cluster that's already been deployed. And what does that actually look like? And again, all of these things that we're doing here from the UI, you'll be able to do from the CLI as well, or the API, which is really where you'll do things going forward. So when I look at my overview page, I've got my cluster ID. If I ever needed to contact IBM support about some issue, I would need that cluster ID. I can see my Kubernetes version, the location, who created it, which is actually pretty important. In my account, I have multiple people that have access to create clusters. And if someone deploys some large cluster and is blowing out my budget, I want to be able to know who created it, who do I need to go yell at. So that's right here in the console for you. I've got my subdomain. I could also bring my own cert, bring my own domain. If I had a legitimate domain, I could bring that and use that for my applications. On the right-hand side, I've got the number of worker nodes that I currently have in this cluster. I've got 4. They're all ready and healthy, which is obviously great news. For monitoring and logging. So here, I don't have logging enabled yet. But if I click on this, it's really just a click of a button. Now I've got those 4 log sources that are being deployed. I could go out and look at each of those. I've got metrics, so I can go out and click this link. It'll take me to the monitoring dashboard. Now, another thing that's you may have noticed here, to get to the Kube dashboard, typically you have to go to the command line, run kubectl proxy. It's a bit of a challenge to be able to do that. We've brought that into the console, into the user experience to make it simpler for you to do that. So that way, in my IBM Cloud Console experience, I can go here and get I can get my Kube dashboard. I mean, this is exactly Kube dashboard. We've not changed anything. So the same kind of user experience that you're familiar with, you'll have. So I can click and I can see, here are my sample jobs that I got running and different agents, but giving you that insight right here just to make it easier. So the last thing that I show you is some little detail on the worker nodes. We can see here that I've got those 4 nodes that I talked about. I can see the machine type. These are all 2 CPU, 4 gigs of memory, the different networks, the hardware isolation. Now, when I deploy this cluster, maybe I aim too high or too low from a capacity perspective. So if I need to add nodes, I can go in here, click add node, and add any flavor. They don't need to be consistent, as in I don't need to always add this 2x4. If I need something larger, I can deploy whatever flavor I want. I could say 1, 2, 10, however many, and add worker node. So now this is going to go out and deploy a larger flavor worker node within my existing cluster, just giving me some additional capacity. I could roll through and upgrade. And then lastly, as I select a worker, I can reload it, I could reboot it, I could also update Kubernetes. So if when 1.10x comes out and is available, I'll be able to click this and go through my cluster and upgrade those sequentially. And when you click that button, we'll drain all of the pods from that worker node and redeploy it, basically upgrading everything in the entire stack. So again, extracts the complexity from you having to manage the entire, just focus on your business objectives. So with that, I am now going to stop sharing and hand it back over to Dan so we can take a look at Codefresh and how that can help you through this DevOps pipeline. Dan?
Perfect, thank you. So just to reiterate, we're going to show how to get from the git commit to the deployment. So let me share my screen. All right. So to start off with this example, I'm going to show this application. It's called Let's Chat. It's got a Node.js image that's running, and it also has a MongoDB that's attached. So it's been defined as a Helm chart. So we have our application defined in a single place in sort of a package. And to demonstrate this whole thing, what I'm going to do is sort of back into it, and we'll explain it as we go. So here you can see I've got the page, and I just got a bug report that the background image is broken. And I can see that the background image is indeed broken. So what I would do here, if you remember, I said that I want to have a rollback capability, and then I also want to have an automated deployment capability. So let's say that I don't want to debug this at all. I just want to roll back to what I was running. I would go over to Codefresh, and you can see I have these sections for my connected repositories, for the builds that I've done, for the images I've created, and then I've got Kubernetes over here. And I've already gone through the work to add in 2 different IBM clusters. You can see I have some other clusters here. I have multi-cloud support, but I'm working with these 2 IBM clusters right now. I'm going to go back to Kubernetes, and I can see that this is the production instance. And if I just want to issue a rollback, I'll go to releases, and under production, and I can look at the history of everything that's gone out on this, and I can issue a rollback. Now, what this will do is it'll take me back to the state before the last release. Now, in this case, I actually want to dig into and understand why the images were broken. So what I'm going to do is I'm going to look at the currently running services. Again, these are clusters, these are namespaces, these are services. And I'm in the production cluster. I'm in this service is the one in question that's serving the bad images. And you can see here the image that's currently running. Now I'm going to click on that. And this is going to show me that this has been deployed to production. This I knew. It has a functional testing that has been passed. It has a JIRA ticket associated with it. It has unit test coverage, and unit testing is passed. I can see that I'm the one that created this. Today was awesome. So let's go look at the change to understand what changed with this and why it happened. Well, here's the issue. Somebody issued a fix called break images. And I issued this fix, and I added this superfluous URL, which then made it through testing. Now, why did it make it through testing? Well, I didn't have a test to see if the background image works, so that's why. So I'll make a note to do that, and let's issue a fix, and then we'll see how this whole thing actually works. So let me open up Git here, and let's go fix this thing. This will fire off my pipeline, my webhook, and everything so that it will deploy automatically. There we go. So we'll save that. We're going to commit it. We're going to say fix images, and we'll push that. Okay, now this is going to push into GitHub, and GitHub is going to fire off a webhook to Codefresh, which is going to kick off this pipeline that is connected here. So let's go look at the repository. Here you can see all my repositories I've connected. This one's called Demo Chat. And let's go look at the builds, and we'll see that it has kicked off a new pipeline to fix those images. And while that starts to run, and it should take less than a minute or a minute and a half or so, let me show you what's actually running in this pipeline, the steps. So here you can see the pipeline I have connected. You can see that it's triggered to build on the master branch only right now. I might have that on development branches. You can see I have a number of environmental variables here. Now in this case, I want to reference environments. One of the environments I want to reference is what I'm calling staging. And this is just the name of the connected cluster because those credentials are managed through Codefresh. Because you remember earlier I showed you that we added the IBM cluster. Now, if I go down to the workflow, we do have a visual editor, but here I've opted to use the YAML for completeness. And you can see there's a build step. This is a built-in step. There is a create a namespace step, which is because I'm releasing to a staging environment first. And then there's a validation step. Now, what I've done with this validation step is I've actually removed all the actual validation for the sake of this demo, and it's just going to report that the validation is working. So it's a bit of a lie just because the validation would probably take about 5 minutes just for the sake of time. But you can see here's how I set the metadata on the image. And then finally, it will release to production. So what does that pipeline actually look like? Well, if we go back to our builds, we'll see that this is completed. So it cloned the repo, it built the Docker image, it didn't need to create a new namespace in this case, it deployed the Helm chart to staging, it ran functional testing, and then it released to production, and it did it all in about a minute. Now, one of the reasons this is so fast, besides me disabling the real functional testing, is that all of these steps in this pipeline actually run on Codefresh in their own container, and they have a lot of caching enabled to make life very easy. Now, building this Docker image from scratch normally takes about 5 minutes, but because I've cached all the layers and the only thing I'm changing is at the very top layer, it's actually building, at like light speed here. And if we go back and refresh this, fingers crossed that this demo works. We should see, oh, good. Wonderful, yes. The background image is there because we issued the fix. Everything ran properly. Beautiful. Oh, I love it when a demo comes together. Now, if I go back and look at my Kubernetes dashboard here, and we'll see that my, and actually, you know what I'm going to do? I'm going to filter out for the master namespace, which is both on my staging and on production. So here you can see the two clusters, the two instances. We can see that they are now running the same image. And if I click on that image, we'll see a very similar report to what we saw last time, except this time the commit shot is going to be for the fix where we deleted this, whoops, and I got the fix working. So this is a kind of a simple build, validate, and deploy workflow But one of the key things here that makes working with Kubernetes unique and working with containers unique is that you're validating multiple containers. You're validating your entire application. And you can see that when we look at the releases, where we have both of these releases on 2 different clusters, and they're following now basically the same revision pattern, except the test cluster has more revisions. Some of them didn't make it into production. And if I needed to go in and into my production, I can see what's running. I can scale it up if I need to. I can also go over to the history, and I can view the changes. So as the chart goes, now in this case, there's no changes to the chart, but I would see a diff here. I can issue the rollbacks. I can view the chart. I can see what values were passed, and I can see the actual Kubernetes configuration files that were generated by Helm. So this gives you an idea of what it means to bring all of it together to solve provenance, and how in a real world scenario, this is going to make your life a lot easier to debug and understand problems. Now, there's another side, which is just like the compliancy side of having a whole history of everything that's happened, and that's sort of built in to the platform. So I can see, when I look at an image, I know exactly where it's been and what's happened to it. And of course, I can have any kind of functional validation that I want. And we're actually doing a webinar next week where we're going to be working with stateful applications. We're actually move live data in, and we're doing another event with Sauce Labs and Testum, where we're going to show exactly how that functional testing component works. But the idea with this demonstration and this webinar is basically to show, look, if you connect up that, you can bring that IBM cluster, and now you can hook up all your workhorse here that's actually going to start taking code, building the images, deploying them, validating them, promoting them, all of these elements. And it's basically bringing it all into one place. And this is actually maybe a good segue into kind of the questions, but we do have support here to work with any Docker registry. So IBM has their excellent Docker registry that has security scanning built in and things like that. And we could actually integrate that in and add in annotations for security reports or any of those kinds of things. Because the real power of the Codefresh pipeline is, again, every step is its own container. So even if there's not like a plugin that's official for doing something, there's a Docker image that has the utilities that you can just pull in and execute with. So that's a ton of information, and I went really fast. So hopefully it was clear, but as you have questions, let's go through those questions. And then I'm gonna stop the screen share, and we'll jump forward maybe to slide 40, and we'll take the Q&A.
Thank you, Dan. That's a great presentation. Thank you, Chris. We do have a Q&A tool for audience members to send in questions. We do have a few here, so I'll start with Chris. As far as figuring out how to size your worker node cluster, what are some of the common problems that have come up in your work with clients of the managed system?
That's a great question, because that actually comes up a lot as far as how do I size my cluster. And sometimes people will try and go from, I'm running X number of virtual machines with this amount of capacity, then obviously I need the same size in worker nodes in my cluster. But that's typically not the case, because when you look at your virtual machine utilization, it's not going to be pegged at 60, 70, 80%. So you really need to look at the application resources required and think about, am I actually developing microservices, or am I taking some application and repackaging as a container? So those are kind of important things to think about. The actual capacity required from a CPU and memory perspective for those containerized applications. Then based on that, you really want to look at the worker node flavors in your cluster that can accommodate all of that capacity. And you're really going to want to use larger flavors so that way there's flexibility to move those workloads. If you upgrade a worker node, that there's capacity for Kubernetes to move those deployments.
Can I actually add on a little question to that? How does IBM Cloud handle auto scaling? I'm actually unfamiliar with that.
Yep. So from the cluster perspective, today you'd have to manually scale out and deploy additional worker nodes or larger flavors if you ran into a capacity issue. We're working on a similar concept as far as node pools and be able to set a policy that allows you to scale up. If I exceed some capacity metric for some duration, automatically add X amount of worker nodes. One of the things that's important to think about is that given virtual machines are billed hourly and bare metal are deployed and billed monthly, you need to consider that in this auto scaling policy because obviously much less dynamic when you think about bare metal provisioning and duration.
Gotcha. Thanks.
So along those lines, based on what you just said about assessing costs and other resources, how would you recommend making scaling tests part of the DevOps pipeline? And I guess each of you guys could address that.
Great question. So we've actually done integrations with a lot of different performance testing, and I have a demo that I could show. I won't show it now, but I could show you a performance testing test where we actually deploy something in a one-off and then run performance tests against it. And in terms of testing the performance should be a leading indicator of how your application is going to work, and then it's going to basically have a direct correlation with whatever resources you put against it. Chris?
Yeah, so I think what's nice about automating and really writing everything as code is that allows you to build in that scaling. Think about it, so that way you don't hit your scaling test once you're running in production and your app becomes wildly popular and now you're trying to figure out how it actually performs. And Dan showed you in the demo how you can increase the quantity of your deployments. You could then deploy that to multiple clusters, different clusters in different clouds, and kind of ensure that your application and different microservices within your architecture can actually perform at that scale before you roll it out into production.
Okay, and then this is another question to both of you guys. Chris, you talked a bit about vulnerability advisor, scanning containers in various states and in different parts of the environment. How would that integrate with a pipeline that you build up with Codefresh?
So from our side, it's all API driven. So Vulnerability Advisor, today it only works if you're storing your images in IBM Cloud Container Registry. If you're using some other registry of source, whether it's Quay or Artifactory or Docker Hub or any other registry that you build yourself, then you would need to really bring your own vulnerability scanning tool. But let's just assume that you're storing your images in our container registry using Vulnerability Advisor. You could add a stage in that pipeline that checks for compliance. And if that image has known vulnerability, you could literally stop the deployment train right then and force users to remediate that base issue before you deploy your workloads.
We do work with the IBM container registry, so you would just add that as one of your registries. And like Chris said, push the image into that registry and then have a follow-up step that will go and check the status of that scan. And that's actually very easy to do because we basically just have we would just have a Docker image that has the I think it's called the Bluemix CLI or IBM CLI, and it would just report and ask that image, ask what the vulnerability status is, and then depending on the result, we can annotate that information onto the image within Codefresh, or we can make a decision to deploy or not, or maybe just to alert someone.
Yeah, and so following up on so the point of the versatility of Codefresh is well taken. Another question along those lines, DevOps teams they like particular tools that they have been working with. So if they bring tools to establish the pipeline with Codefresh, how would they integrate them?
Yeah, that's a great question. A situation that we run into very commonly, for example, is people come in and they say, look, I've got 250,000 Jenkins jobs. If I tell people that we're going to switch to Codefresh, I'm going to get strung up. So what we did is we created a Jenkins plugin for Codefresh, so that you can have us do the part that we're really good at, and you can basically just integrate it right into Jenkins and just have a step that fires off a Codefresh pipeline to run. And what we find is that as people containerize, they typically just move everything over to Codefresh rather than keeping anything in Jenkins. But it makes it very easy to kind of get started, dip your toe in the water, start working with things, get a proof of concept going, and make people in your organization feel safe that they're not biting off this giant, migration path or anything like that. But and then in terms of just other tools, as long as there is a kind of containerized element to it, we can just put them right into the pipeline. You can actually, and I haven't done this, but you can actually have a step in Codefresh that spins up Jenkins and has it run jobs and then spins it down. So it is the versatility aspect of it leads to some kind of funny concepts, but yeah, you can definitely bring in and integrate any tools that you want. And as an example, I did a meetup with JFrog a few months ago, and they had just added a Helm repository into their offering, and we wanted to demonstrate working with that Helm repository from Codefresh, and it literally took me like 5 minutes of work to just pull in the Artifactory CLI image, execute a command, and call it a day. I mean, it was really that easy.
Well, let's close this out with a sort of forward-looking question. It's sort of implied in part of the discussion already. The evolving container-based application development space seems to be moving towards multiple cloud support. Vendors or businesses don't want to be locked into a particular vendor. So can you guys end with some thoughts on how the managed Kubernetes service in IBM Cloud and the Codefresh DevOps tooling will enable that to happen for businesses that want to go multiple cloud?
Sure, I can start with that. And I mean, that's really the premise here of Codefresh, is to simplify that multi-cloud or hybrid cloud, whether it's an on-prem or an actual public cloud, supporting those workloads. And even in the demo, Dan showcased that, in this, today we're using IBM Cloud, but we also have support for Google or AWS or Azure. So as your workloads, and whether that's different project teams that are using different clouds for maybe some capability that is unique to a given cloud, or just maybe a public cloud is not available in a geography that another cloud is, so we want to deploy co-located with some other workloads. The premise of being able to use consistency, to use that same tooling and just basically fork at the end and deploy from one cluster to another, is really the power of Codefresh. And because, definitely within IBM Cloud, and I think other cloud providers as well, by building on these open standards, especially Kubernetes as the container orchestration tool of choice, using that consistent CLI and API makes it easier for you to redeploy those workloads in that multi-cloud kind of environment, because it's using consistent. It's just a different authentication to a different cluster running in a different cloud.
That's exactly right. And one of the common things that I see there are a couple of scenarios that I see very commonly from our customers. We'll have, for example, retailers who are using AWS, and because they're retailers, they don't want to be using AWS because they feel like they're using a competitor's product. And so they want to figure out how they can start migrating. And the first thing they'll do is just connect a cluster, from another cloud like IBM and start dual deploying. And this gives them the confidence that what they're doing is going to work, because they're actually getting what they have onto another space. The other thing that I would say on that is it's very common for people to do hybrids where they want to have an on-prem and a cloud offering. And actually, that's one of the things that makes IBM unique, is just the bare metal kind of support for running Kubernetes, which is really cool. And if you do want to do that, you want to dual deploy. Well, the demo that I showed you actually is a dual deploy. It's actually dealing with 2 different Kubernetes clusters. It doesn't matter where they are. They could be anywhere. They could be on IBM, they could be on Google, they could be on-prem. It's going to be the same situation. And even on-prem, we have some tools for dealing with the firewall and how we interact with that. But all I would need to do, just like Chris said, is just change the name of the cluster in the pipeline or in the environmental variable. And the cloud it's now going to push into a different cluster. Yeah, very straightforward.
And thanks to you, Chris, and the audience for joining. You can see the contact information there on your screen to get more information about either IBM Cloud Container Service or Codefresh. And look for a follow-up blog on the IBM Cloud blog for answers to any questions that come up as this webinar remains available on demand. And we'll look forward to seeing you next time.